is R alpha? Because now we know that one of the root of the generator polynomial is alpha, so which is same as the root of the generated polynomial. So the root of the generator polynomial is known, which is alpha. So when we will receive another code bits, then that received code polynomial should possess the same roots, which is alpha, or the roots of the received code polynomial should match with the root, the known roots of the generated polynomial, which is alpha. Or you can say that root alpha should presented in the received code polynomial. So that's why when I'm using the received code polynomial, so that's why this R present here, okay, R alpha. So this become our first syndrome. I hope you can understand it. So as the degree of the generator polynomial is 3, because the generator polynomial was 1 plus x cubed. Okay, so the generator polynomial, the degree of the generator polynomial was 3. So I have told you that when a polynomial equation possesses a degree of m, okay, then the number of the roots will be also m. So here the generator polynomial equation is of degree 3, but we have yet computed only one root. So we have to calculate the other 2 roots. Okay. So the first root we have got, which is alpha, done. And from using that alpha root, we have made our first syndrome equation, which is S1 equals to R in R alpha. Okay. So there are still 2 other roots. Here it is written that there are still 2 other roots to be found for this polynomial, right? By substituting alpha square. So let us see that whether by substituting alpha square we can make generator polynomial as 0 or not. If this is 0, then we can consider alpha square as the second root of the generator polynomial, 1 plus x cubed. Okay. So here we have considered g1 alpha square. So we are replacing x by alpha square, and we are observing that whether the equation becomes 0 or not. So when we are replacing it, 1 plus, so in terms of x, so 1 plus x's cube was our main generator polynomial equation. So x is replaced by alpha square, so 1 plus alpha square plus alpha to the power 6, because alpha cube alpha square whole cube, so this is alpha 6, and we know that alpha 6 equals to 1 plus alpha square. Again we are using the syndrome results from our cyclic code. So go to the handwritten note that from this table x to the power 6 equals to 1 plus x square. So this result is being used here also. Alpha to the power 6 means 1 plus alpha square. Again this addition is an XOR addition. So this is making this equation as 0, right? So here we have seen that if we replace x by alpha square, assuming the root of the 1 plus x's cube, the generated polynomial equation we can make that equation equals to 0. So this is the condition. This was our condition to calculate the root. So alpha square become our second root of 1 plus x cube, right? So we can say alpha square is the second root of the generator polynomial equation. And as you know that the root of the generator polynomial equation is same as the root of the generated code polynomial. So when we will receive some code, polynomial, and we will derive the roots of the received code polynomial, so there should be a root to be present which is same as alpha square. Then only we can say that received code is a error-free code. Okay. So this verifies that alpha square is a root of generator polynomial. This is also written here, that is G1x, and the Hamming code, the C cyclic code 7,4, and so it is also the root of any code polynomial of this code, which I've told you, allowing us to form a second syndrome equation, which is S2 equals to R alpha square. Okay. Now, the thing is that, so our generated polynomial equation was of degree 3. So the number of the root was 3. But yet, till now, we have already computed only 2 roots of the generated polynomial, which is alpha and alpha square. So again, we have to find the last root. So we have found that alpha to the power 4, if I replace x with alpha to the power 4, this also making the equation as 0. Okay. So our third root of the polynomial, the generator polynomial, is alpha to the power 4. Okay. So the thing is that we have considered the Galois field of order 2 to the power 3, where 3 was the highest degree, right? And considering that highest degree 3, our generator polynomial we have chosen as 1 plus x's cube, right? Now, also we have computed the possible roots of this generator polynomial equation, which is alpha, alpha square, and alpha to the power 4. Now, go to my handwritten note that when we have considered m equals to 3, so this was our possible polynomials, right? So x's cube means 1 plus x. We can also consider x's cube plus x square plus 1. Also x's cube plus x plus 1. So this was our possible polynomial equation considering the degree as 3, right, in the Galois field. But from that Galois field, we have considered only x's cube plus x plus 1, that means this, as our generator polynomial equation. and